Today's lesson is going to revisit some of the concepts we looked at yesterday, but in a different way. So as a reminder, we've got the vertical line test. If you place a vertical line on a graph and it touches the graph more than once, it is not a function. Domain is the input, or what x values are legal to substitute into the function. And the range is the output, or what values come out of the function. Today we're looking at reading information from a graph. So we're going to be looking at lots of different concepts. Starting off with domain. Reading domain from a graph, you can kind of think about sliding a vertical line from left to right. If the vertical line touches the graph at all, those x values are part of the domain. For our graph, we have these arrows here saying that it continues forever in both the negative and positive direction. So our domain is all real numbers. Anywhere we place a vertical line on this graph, it will hit the graph, meaning those x values, all x values, are part of the domain. For the range, you can think about a horizontal line sliding from the bottom of the graph up. Anywhere a horizontal line touches the graph is part of the range. It is outputs that are generated by the function. In this case, sliding a horizontal line up through the graph will hit the graph everywhere up to this point right here. Now it looks like the graph falls a little bit short of 8,000, but we're just going to round up to make it easy on ourselves. So the range is from negative infinity up to, but not including, 8,000. X-intercepts. These are where the graph crosses the x-axis. I see an x-intercept here at 0, 0. And I see another x-intercept over here at what appears to be 125, 0. For our y-intercept, it crossed the graph at the origin, so that x-intercept of 0, 0 is also our y-intercept. F of 40, evaluating the function at 40. So what we do is we look over to where 40 is on the x-axis and then slide up to where it hits the graph, and we read that point. It looks like it's just shy of 7,000. And finally, is this a function? Using the vertical line test, because we're looking at a graph, if we slide a vertical line across the graph, I don't see anywhere that it would hit the graph more than once. So yes, we have a function. All right, doing that again. Domain, because of these arrows, the graph will continue forever towards negative and positive infinity. So we again have a domain of all real numbers. Our range would not hit the graph if we're thinking about a horizontal line sliding up the graph from the bottom towards the top until we get right about here, which looks like it's just below 300. I'm going to estimate that at 325, and it goes up from there. I'm going to use a closed bracket because it looks like it does touch the graph at 325 and goes up from there. Remember, never use a bracket for infinity. X-intercepts, where does our graph cross the x-axis? We have ours labeled for us nicely here. We have 3 x-intercepts at negative 4, 0, 0, 0, and 4, 0. Only one y-intercept, again, the origin, that x-intercept and y-intercept the same. Evaluating our function at f of negative 2. So we find that x value of negative 2, go down to where it touches the graph, and it looks like it's about negative 250. And finally, is our graph a function? Does it pass the vertical line test? Again, it looks to me like it does, so yes, this is a function. This time we have what's called a piecewise function that we'll be analyzing. Notice how the graph is disconnected. It has open and closed circles, and it jumps in different places. So the domain might be a little bit more challenging. We're still looking at those x values. We have an arrow here. Now what we have to check is where there's a break in the graph. If we look at the x value of 1, we have an open circle at 3, which means it's not part of the function. But down here, there is a closed circle. So there is an input of x equals 1, and the same thing happens at x equals 2. There's a closed circle as well as an open circle. Off to the right, we've got that arrow going towards positive infinity. So once again, we have a domain of all real numbers. Now for our range, thinking about sliding a horizontal line up the graph, it does not start touching the graph until 0. Because of that curve off to the left, we do have y values all along from 0 up to positive infinity. X-intercepts, we're only touching the graph in one location this time, at 0, 0, which is also our only y-intercept. We have a different question for part E this time. Where is the output for this function 2? That means this time, instead of looking at an x value, we're looking at the y value. If you go off to the right and we see this open circle, that means the function is not defined there. So that is not a solution to this question. We have to go off to the left and take a look at it's about 1.5. I'm just going to estimate that. So for x is negative 1.5, we get a y value of 2. And this is a tricky question on this one. Is this graph a function? I kept referring to it as a function, but now we need to check for sure. Looking at those vertical lines, does the vertical line touch the graph more than once? The two places we really need to be careful about are here and here where the graph jumps. Notice how one of those points is a closed circle where it is defined. The other one is an open circle. So technically, that vertical line does not touch the graph at that open circle. The function is not defined there. Every other vertical line that we could slide along this graph would also only touch the graph once. So yes, this one is a function. We'll do this one more time. This time our domain is not all real numbers. We do not have arrows heading off to the left and right. So we'll be able to see how to find a domain that is not all real numbers. Looking at those vertical lines, the first vertical line that touches the graph is there at -5. And it would stop touching the graph over here at -1. The range would be those horizontal lines. We would start touching the graph down at -3 up to +7. All right, any x-intercepts? Where does the graph cross the x-axis? I will be rounding a little bit. They don't cross exactly at -1 and -5, but just to make it easy, we'll say that it does. Y-intercepts, anywhere that the graph crosses the y-axis. In this case, we don't have any y-intercepts. Part E is a very similar question to the last one. It's where is the function -2? So we are not looking at an x value of -2. We're looking at an output or a y value or a range of -2. Sliding over, the graph would be -2 in 2 locations just before we get to -2 and just past -4. So the x values would be -2 and -4. That would make the function or the output -2. And finally, is this graph a function? Hopefully most of you recognized right away that vertical line would hit the graph twice in several different locations, so we do not have a function on this one. And finally, your U-Try question.